Okay, our first example is going to be example 1. How many grams of calcium, not cobalt, of calcium hydroxide are required to neutralize 35 milliliters of a 0.15 molar nitric acid solution. So nitric acid, HNO3. So we have this calcium hydroxide, and we have this 35 milliliters of a 0.15 molar acid solution, and we're going to drop in some calcium hydroxide. We want to know how many grams of it we actually need to drop in there to completely neutralize. And when they say neutralize, they're talking about the neutralization reaction. You notice you have an acid, and you notice you have a hydroxide. So we're talking about H plus OH minus forming water. And again, it's a 1-to-1. 1 H plus 1 OH forms 1 water. Well, let's just write the equation and work from there. So again, the idea is don't just jump into the math. This is chemistry. The idea is write an equation. That's the first thing you want to do. Write an equation, balance it, do anything else you need to do to the equation. Maybe there are 2 or 3 different equations. Maybe you want to break it up into a net ionic, something like that. Whatever works for you, but make sure you understand the chemistry first. The math, again, is incidental. It's something that you'll need, but if you don't understand the chemistry, you'll never be able to do the math because you won't know where to go on the problem. So let's do the equation. So we have calcium hydroxide is CaOH2, and we're going to add that to an HNO3, and that's going to form, so there's going to be, this is an acid-base neutralization, so outside you're going to end up forming water, which I write as HOH, and I just do that because when I'm balancing, I like OH on one side, OH on the other. It's just easier for me. Plus it reminds me that H and OH are actually separate, that the 2 H's are not, well, yeah, in any case. Plus calcium nitrate, CaNO3, and I believe this is a 2. So let's balance this off. Let's put a 2 here, let's put a 2 here, and there you go. 2 H's, 2 H's, 2 nitrates, 1 calcium, 2 hydroxide, 2 hydroxide. Good. So this says that for each mole of nitrate, for each mole of calcium hydroxide, I'm going to neutralize 2 moles of nitric acid. So let's just jump right on in. So let me see, they say how many grams of calcium hydroxide are required. So here we're going to need to go from mole of 35 milliliters of a 0.15 molar HNO3. So we're going to go moles of HNO3. Using a mole ratio, we're going to find moles of CaOH2 and then grams of CaOH2. Okay, so this is just a simple stoichiometry problem, 2 conversions. Great. So let's start by finding the number of moles of HNO3. So we have 0.035 liters, because it's 35 milliliters, times 0.15 mole per liter. Okay. I personally prefer to work one thing at a time. You're welcome to do multiple conversions right on one line. I prefer to do it one at a time, again, simply because I like to see the chemistry at each step. It's a personal choice. I'll let you handle it as you please. So when I do this one, it tells me that I get 0.00525 moles of HNO3. Okay, well, 0.00525 mole of HNO3, and the mole ratio is 2 moles of HNO3 per 1 mole of calcium hydroxide. One mole of calcium hydroxide. Therefore, when we cancel that, we end up with Oh, actually, you know what? In this case, let's just go ahead and do the straight conversion just so you can see it. And then 1 mole of calcium hydroxide, the molar mass is 74.08 grams. And when we do that times that divided by this, we should end up with 0.194 grams of calcium hydroxide. So that's it. So if I have a 35 milliliters of a 0.15 molar nitric acid solution, I need to drop in 0.194 grams of calcium hydroxide to completely neutralize the acid. In other words, what I'm adding here is base hydroxide to H+, the hydrogen ion, which is acid, to neutralize it to form water under this reaction. This is a standard neutralization reaction. Acid plus base goes to water, and the salt is calcium nitrate. Acid plus base goes to salt and water. Always, always, always. Okay.